This is going to go over composition of functions with an example that demonstrates what happens with the domain of the composite. What we're going to do is actually do d of b of x, which means that we're going to take the b function and plug it into the d function. Now, starting off looking at the domains of the original two functions, this one is x is greater than or equal to 0, and this one is all real numbers. But when we take this and we plug it in, we get d of the square root of x. You sort of stop right there and just look and make sure, yep, our domain has to be restricted to x is greater than or equal to 0. Continuing on, we then take that, plug it in, we get the square root of x squared minus 1, showing a substitution step. And that will simplify to x minus 1. And our domain on this is just all real numbers. Since the domain, d of b of x is the intersection of both of these, then our domain would have to be x is greater than or equal to 0. Now, some may ask, well, why when you look at this function here, how can you see that x is greater than or equal to 0? And you can't. You have to think about composition of functions as a process, or a journey. We're starting with x, and then we're going to transform x into d of x using the b function. Then we're going to transform b of x into d of b of x. And since it's actually a journey along the way, think about it like this. If we go from x to b, values, but we also greater than or equal to 0. So once we have our b of x, we are only doing those for x's that are greater than or equal to 0. Then when we take this to here, we still have this domain that's carried with it. Another way to think about it is, if I go from x directly to there, using this function that we created, the x minus 1, or the composite, there's no way to know, looking at that my domain would have been x is greater than or equal to 0. But we have to have our composition have the same result. This has to be the same result as if we were to go from here to here, and then from here to here. So the only way to do that is to list the original restriction of x is greater than or equal to 0.